Greetings. Welcome to our 52nd episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign, and also technical director of the FGI. On today's episode, we're going to focus on our February 8th, 2024 webinar titled Protecting Water with Flexible Geomembranes. I'd like to quickly reintroduce our speakers. First, Brian Fraser has been working in the geomembrane business for 44 consecutive years, including manufacturing, fabrication, and construction. He is currently the vice president of Layfield Geosynthetics and is responsible for business development in the United States and internationally. The other webinar speaker is Rohit Sati. He is also a member of Layfield's Technical Services Group and is the technical product manager responsible for geomembrane containment products. Rohit has been employed with Layfield for 18 years in various positions, including engineering business manager, technical sales support, and responsible for product development of Layfield's geosynthetic products and services. So Brian and Rohit, thanks so much for joining us again.
Thank you, Tim.
Thank you, Tim. Yep.
Great. So thank you for an excellent webinar on using flexible geomembranes for protecting water. We received a number of questions during the live webinar that we were not able to answer, as well as some follow-up questions that were submitted through the survey that was distributed after the webinar. So here we go. I'm going to start with the questions from the live webinar first for you. Question number one, with PFAS recently coming into the spotlight due to its environmental persistence and health risks to the general public, have there been any discussions regarding PFAS use in these geomembranes and potential future regulations and implications for its use in geosynthetic products?
So I'll take that, Tim. We're not familiar with any current regulatory requirements in terms of geomembranes and their use with PFAS. We as a manufacturer and many other manufacturers are certainly well aware of the concerns with PFAS, and I think most companies today are auditing the formulations with their supply chain, looking at the resins, additives, etc., to ensure we don't have PFAS components in our formulations. In addition, we're testing most of our materials to look at chemical resistance and diffusion rates, etc., with the various geomembranes. Again, this is all going to vary by polymer type and formulation, but I think the industry in North America is well aware of the issues and proactively testing their materials. We are getting requests from owners and operators to ask us and verify that our geomembranes do not have any PFAS components inside of them, and we're addressing those on a one-by-one basis.
Okay, great. Question number two. Does Layfield manufacture any of these geomembranes or focus on installation services only?
So Layfield is a vertically integrated geomembrane company. We're involved with the manufacturing of geomembranes and geonets and geocomposites. So in terms of the geomembranes, we produce HDPE, LLDPE, we produce polypropylenes and various flexible grades of alloyed blend materials, polyolefin alloy blends, more specialty type higher performance geomembranes. In addition to manufacturing, we do run 3 fabrication plants where we work with many materials, not only materials that we manufacture, but materials like PVC, PVC EIAs, reinforced polyethylenes, CSPE, etc. So we're, from a fabrication perspective, we work with most materials, most mainstream materials. And we have construction groups doing installations, both based out of San Diego, California, and Edmonton, Alberta, Canada.
Yep. Okay, number 3. Are there any case studies / examples of woven coated polyethylene geomembranes being used for permanent barrier as the permanent barrier layer in a final cover system?
Tim, I mean, I looked at this question and I spoke with a couple of woven coated manufacturers in the US, and they're not aware of this, but they think, I mean, because the product is actually sold through fabricators, I mean, many times the actual application isn't shared. But I can definitely confirm that this material is being used as temporary caps. And I think with the advancement in woven coated polyethylene film technology, I'm pretty sure these materials could be used as permanent covers in 30 or 40 mil grade.
Okay, great. Thanks, Rohit. Number 4, could you please give more information about the UV resistance and specify the lifetime of a geomembrane?
Sure. So yeah, I mean, it all depends on the application, whether it's exposed or whether it's covered. In covered applications, there are multiple types of geomembranes that can be used, and here you're only looking at weathering resistance minus the UV. But if you have an exposed application, and UV is one of the critical factors, I mean, you probably are looking at a UV stabilized geomembrane. I mean, there are unsupported geomembranes we know that would offer long-term UV resistance, I mean, in tune of anywhere from 20 to 25 years. Um, I mean, this is where the geomembrane will lose all its antioxidants. With wovens, I would expect this to be especially in exposed application, anywhere from 10 to 15 years. So there are geomembranes that are highly stabilized with UV and antioxidants or additives that will give you really good performance, even at a thickness of 30 or 40 mil geomembrane thickness.
Okay, great. Thanks. Thanks again, Rohit. Number 5, could you please give more, number 6, what about the use of reinforced polyethylene for use as a temporary cover at a landfill to control odors and gas?
Yeah, Tim, yeah, in commonly we see or we use the both the lighter weight woven coated polyethylenes or even some of the middle range reinforced polyethylenes are commonly used for temporary covers in a landfill. Again, normally in applications probably under 5 years until the landfill is ready to move forward with a more permanent cap and closure system. So, really commonplace to make large prefabricated panels, and these are being used for, again, temporary caps. They can be ballasted down, sometimes with sand tubes or tires. They're not normally looked at a full-scale installation, i.e., doing all the field welding with these temporary covers. In addition to temporary covers, we also are using the woven coated polyethylene materials for daily landfill covers, and that's an application as well for odor controls that various landfills use. So both temporary covers and daily covers are using the woven coated materials.
Great. Okay, last question from the questions received during the webinar. What is the maximum design velocity that the geomembrane could withstand?
Okay, I'll take that question. I mean, it's an interesting question. I mean, it's hard to just give a quantitative number in terms of what the velocity would be, because there are certain factors that you have to consider. But if you really want to get more details on designing, where you're looking at geomembrane as a canal liner, because I think you're referring to a flow velocity. I mean, I would suggest you look at, some of the technical papers out there. There was one recently published, in 2023. This came out of this Geo Africa conference. GP Giroux and a couple of other authors actually, put a very detailed document on this. And I would encourage you to look at that. They even referred to a full-scale test of geomembrane uplift by flowing water, where they talk about the test was where the flow velocity was around 1 meters per second, or about 3.28 feet per second. They used PVC as well as HDP in this testing, and the test included a thick non-woven geotextile underneath the geomembrane. So again, I mean, there's no straight answer. I mean, it has to be designed properly. But I would, if I had to put a number, I would say, I mean, right around 1 meters per second to anywhere up to 4 meters per second. So 3 feet per second up to 12 feet per second. I mean, that's pretty high, but that's what you're going to see, like, especially if the geomembrane is not covered and you have flowing water, because there's literally no resistance. So that's why in many canal applications, they will actually put a ballast on top of a geomembrane, which basically dissipates the energy of the water. And that is something that's desired in some of these applications.
Great, Rohit, thanks. And so 3 to 12 feet per second is the range.
Well, this is what you can expect. I mean, for exposed geomembrane.
Yep. Okay. And again, for the listeners, that's the velocity, maximum design velocity for water or the liquid. Okay.
Yes. Yes.
Okay, great. Thank you, Rohit. And that ends the questions that we had remaining that we received during the webinar. So we have 2 questions that we received after the webinar in the follow-up survey. Number 1, do you have any additional information on brine pond construction, materials that should be considered for brine pond construction, etc.?
Well, I mean, again, I mean, when you're looking at construction using brine, I mean, a lot of times, like for example, we looked at this application in Australia where they're pumping brine at very high temperatures. So you have to take into consideration some of those factors, like temperature and the brine concentration itself. Brine is actually pretty saline. I mean, much higher than the salinity of seawater. So it definitely will have, and especially when the temperature is added to that, it can double down on the geomembrane. So geomembranes have to be qualified for this type of an application. For example, like Layfield has done some brine testing on thin film geomembranes. We are looking at antioxidant retention. So if you're using thin film materials, definitely you want to make sure that they're stabilized to actually handle brine containment, for a longer term applications.
Okay, great. Thank you, Rohit. Last question. Do the wrinkles in the above water tanks do not have a negative effect on the durability of the geomembrane? So I think they may be referring to one of your figures or photographs.
Well, we don't find really any problems, Tim, with most of the flexible geomembranes, and we make different types of tank liner configurations, from bucket liners where our main seam is on the bottom perimeter, that we're using primarily for water tanks, to staggered liner construction where we're prefabricating these all in one piece, being used a little bit more in upstream oil and gas for these hydraulic fracturing of flowback waters. And those normally are those larger tank liners typically have more wrinkles. Most of these are being done with either linear low density polyethylene or reinforced polyethylene or reinforced PVC EIA material, and we don't really see any problems with wrinkles with those types of materials. And in some cases, in certain materials, we actually try to put a few extra wrinkles in there with the unsupported materials for slack, dealing with different contraction, expansion throughout the year with temperatures. So my point is, with most flexible materials, wrinkles are not a concern to us.
Right. Okay, great. Thank you, Brian, for that answer. And that is the last question from the follow-up survey. So thanks to Brian, Fraser, and Rohit Sati for an excellent webinar titled Protecting Water with Flexible Geomembranes, and joining us again to address the questions that were received after the webinar and that we couldn't answer during the webinar. Thank you to all who attended the webinar and listening to this podcast. Again, Brian and Rohit, thanks so much for an excellent webinar and answering these questions. If you have additional questions or would like additional information, please send your questions to fabricatedgeomembrane@gmail.com or visit the FGI website at fabricatedgeomembrane.com, where you can download the slides as well as listen to the webinar again. So Brian and Rohit, thanks again.
Thank you very much.
Thank you, Tim.
Okay. Thank you.